So let's look at our first example here. 2x is less than 10. So if I were to solve this just like I would an equation, I would divide each side by 2 to get my variable on one side by itself, and then I have x is less than 5. That means that for our inequality to be true, then x has to be less than 5. So let's look at this for a moment. That means that there is more than one value. 2 times 4, I would get an 8, which is less than 10. That would make the equation true. What if I tried something like 0? 2 times 0 would actually get me a 0, which is also less than 10, and also make the equation true. And the same goes for a negative integer. So if I had 2 times, let's say, negative 3, that would actually give me a negative 6, which would also make the equation true. So my solution set in this case is going to be more than one value. And how do I write that? Well, in a graph, my solution set counts on x being less than 5, because if I were to put in the 5, and that would make this equation false, because 10 is not less than 10. 10 is actually equal to 10. So it cannot be 5. When I graph that, I'm going to have an open circle around the number 5. And then using an arrow, I'm going to indicate that the values to the left, which would be values less than 5, are actually possible solutions. So let's go ahead and try this second equation right here. This one's a little bit different because it has that equal sign. We're going to go ahead and divide each side by negative 15. When you do that, you're going to switch over the sign, because anytime you are dividing by a negative integer, to switch the inequality sign. So 45 divided by 15 is going to give me a positive 3. This number should be greater than or equal to negative 45. Now let me see. Negative 15 times positive 3 is going to give me a negative 45, which is equal to negative 45. So what if I plug in a negative 3 instead of a positive 3? If I do that, my product of negative 15 and negative 3 is going to be a positive 45, which is indeed greater than a negative 45. So that would also make the equation true. Now let's go ahead and graph it. If I were to graph x is less than or equal to 3, I'm going to grab the number 3. And I'm going to circle it, but also fill in the circle because I am including the number 3. So it's not like this situation that we did previously where I had an open circle because I was not including the number 5 in the solution set. In this case, I am including the number 3. I'm going to grab all the numbers that are less than 3, in this case on the left-hand side of this number line, and I'm going to symbolize that with an arrow going to the left. Using your words, you're going to have negative 15x is greater than or equal to negative 45 is true when x is less than or equal to 3. Now when we write our solution set in set notation, we are going to write it a little bit different than if we would an equation. And the reason for that is because we're going to have more than one value, we need to be very specific about what those values are. So we are still going to have our brackets and write our answers inside the bracket. Now what I'm going to do with my bracket is I'm going to divide my bracket into 2 using a vertical line. On the left-hand side of the vertical line, I'm going to indicate the condition that needs to be true for the variable. So basically what symbol I'm going to use for the variable and what number type. In this case, I'm going to use the variable x, and x has to be a real number. So I'm going to write x real to indicate that x has to be a real number. On the right-hand side, I'm going to indicate the cases where this solution set would be correct. When x is less than 5, it will give us an accurate description of our solution set. Now, if I were to write the solution set for this bottom inequality, x has to be a real number, so I'm going to write for x being a real number, divide my brackets into 2 places, and on the right-hand side, I'm going to write the description. In this case, when x is less than or equal to 3.